Morning. I'd like to start by welcoming everyone to our presentation about the preparation of soil samples with ColdBlock. I'm Craig West, CEO of ColdBlock Technologies, and I'm excited to be sharing these findings with you today. Before we start, I'd like to mention a few details about how this session will run. This webinar is being recorded. So after the session is completed, you will receive access to both the recording and the materials presented, including the data and the application notes. If you have questions during the presentation, please submit them using the Q&A feature in Zoom. I'm surrounded today by the ColdBlock lab and technical teams, and we will be responding to questions after the presentation is completed. So let's get started by talking about current soil testing practices and why soil testing is important. So to clarify, today we're focusing on environmental soil testing. These are the methods that are used to check for soil contamination, testing for heavy metals, toxic elements, or those that may present health risks. This testing is quite common and considered routine in many industries and jurisdictions. It is used frequently at construction sites, large redevelopment projects, and industrial remediation efforts. This is the testing that provides the data that is often required for regulatory compliance in many jurisdictions. It's the data that supports the decision over the land use and the soil remediation efforts that are required. Now, many countries have their own specific defined methods. Here in Canada, we refer to the SW846 methods. In the UK, it's ISO 13657. In Australia, there's AS 4969. Now, all of these methods are very similar in nature, and many, to varying extents, were built off of the original US EPA soil analysis method 3050. EPA's 3050 methods have been around for a very long time. The last update to this method, 3050B, was published back in 1996, almost 30 years ago. Well, arguably improvements are long overdue. 3050 is still a common benchmark for analytical performance. Very often, the adoption of new or alternative methods typically involves demonstrating equivalence to 3050B. So again, unchanged for 30 years, there are limitations around 3050B, and I think they're well understood by everyone on the call today. First and foremost, it's a very long and labor-intensive method. 3050B takes 4 hours and 45 minutes if followed strictly. Now, in many countries, alternatives have been developed, and there has been some optimization of this method, but still, most of the soils analysis methods that are out there still take well over 3 hours. The second shortcoming or issue with the method is really its recovery of volatile elements, including mercury, where often a completely separate method is required for evaluation. There is some complexity with these methods, often multiple digestion pathways or optional steps depending on the elements of interest or on the organic content of the soil in question. As a result, the impacts are, frequently you can see underreporting or at least variability in reporting of some key elements, and that can result in the need for retesting. It's a slow process, and again, it's higher cost. We've all are facing throughput capacity constraints and slow turnarounds. So what does this industry need then? Well, following conversations with many of you on the call and others in industry, I think there's 3 things that we need. First, we need speed, a faster method that can deal with capacity constraints and shrink turnaround times. 2, obviously we continue to need accuracy across all elements in question, and ideally better accuracy with some of the more challenging elements like antimony and silver, and a method that can also report some of the volatile elements like mercury. We need accuracy that at least meets current standards and potentially can exceed current standards. And then 3, simplification. We need a single process, a single stream of steps that are followed exactly the same way every time, and that can handle any soil type. And really, that's why we're here today. We believe that the ColdBlock soil digestion method meets all of these needs, and we're excited to explain to you why. Let's pause for a second and talk about ColdBlock. Now, the science behind ColdBlock sample digestion was developed here in Canada over 10 years ago. We brought ColdBlock to the market with the launch of our Pro Series digesters in 2021. ColdBlock Pro Series digesters have been sold in over 20 countries around the world. It is now being used by some of the largest commercial labs in the industry, as well as many industrial, academic, and government labs. So what's different about ColdBlock? First, ColdBlock uses infrared heating. Unlike other traditional methods that heat the vessel or that heat the acid, with infrared, we are delivering energy directly to the sample. A very precise and importantly, very repeatable way of delivering energy to the sample and into the system. Second, ColdBlock makes use of a cooling zone. At the top of the test tubes, we are cooling them. This promotes the condensation of acid vapors that may rise up through the vessel. It reduces the loss of acids that may escape to the environment. As well, it improves sample handling, and we are reducing cycle times by minimizing the amount of cool down time that's required. So what are the key benefits of ColdBlock? First, regarding speed, we'll show you today how ColdBlock soils method can be completed in 45 minutes, and again, comparing with EPA's 4-hour and 45-minute method. It's important to highlight what that means for sample throughput in a lab. With current methods, you would be pressed to achieve maybe 1 or 2 digestion cycles in an 8-hour shift. With ColdBlock, you could achieve up to 10. So in a side-by-side comparison of ColdBlock versus HotBlock, we can show a 4-fold increase in the throughput per linear foot of vented space that you may be using. We also talk about simplicity and we will show today how the method we've developed is a single process, much simpler than the current soil digestion methods. In addition to that, we talk about how simple ColdBlock is to use. A programmable one-button operation of a digestion system with very low maintenance requirements per week, and a system that's designed for scalability. On the safety side, again, our system is open air. There is no need for the pressurization of acids. And the cooling zone we just spoke about promotes safer handling of test tubes, safer handling of samples. And all of that results in savings. With boosted lab productivity, our customers often report cost savings of 10 to 30% per sample. Now, we spoke about simplicity, and you're not going to be able to read all of the complex details on this slide, but on the left in white, you can see all of the EPA methods. Again, this is a 4-hour and 45-minute process. You can see several optional branches that depend on the elements of interest. And on the right, in blue, you can see ColdBlock. Again, 45 minutes, a single process method with 6 simple steps. But let's take a look at a short video that I think will better demonstrate the method in greater detail.
In this video, we'll demonstrate the digestion of soil samples using ColdBlock digestion technology. 0.5 grams of the soil sample is weighed and added to the tubes. Medium-sized tubes are used for this digestion. 10 milliliters of 1-to-1 nitric acid and 5 milliliters of 1-to-1 hydrochloric acid are then added. The transfer tray allows all tubes to be moved at once, and it's placed into the ColdBlock. The samples are digested at 70% power for 5 minutes. "10 milliliters of nitric acid is added. The samples are then digested at 60% power for 20 minutes. 3 milliliters of 30% hydrogen peroxide is added slowly, and the samples are digested again at 60% power for 10 minutes. Finally, 5 milliliters of hydrochloric acid is added, and the digestion is run at 60% power for 10 minutes. Once the sample's cooled, it's ready for analysis. We recommend bulking to 50 milliliters using ultra-pure water. The digestion is completed in just 45 minutes. This is a remarkable achievement, especially compared to traditional digestion methods that can take up to 5 hours to deliver the same results. For more information, visit us at coldblock.ca.
Let's take a look now at some of the key differences between a traditional method and the ColdBlock digestion method. So rather than having optional steps, we are standardizing the addition of peroxide. We're also standardizing the timing of addition for other reagents. And we're eliminating that variability in 3050B analyst-dependent steps. We believe that this will lead to more consistent results and easier method validation across labs and across sample types. As you've seen in the video, we've optimized the sequencing of acid addition. This results in better solubility and stabilization of target elements in solution. The result is improved recovery for elements that can present issues with traditional methods, including antimony, silver, and mercury. So let's discuss now how the ColdBlock soil method was validated. On the bottom of the slide, you can see the reference materials that were used in the validation of the ColdBlock method. Why these CRMs? In our discussions with the EPA and with subsequent investigations, we learned that these were the CRMs that the EPA was working with to validate an updated 3050 method. So we chose to use the same CRMs. Our validation was performed using the ColdBlock Pro Series CBM digester. Analysis was completed by both ICP-OES and ICP-MS, though all of the data that I'll present here today was from the ICP-MS. Key parameters were evaluated, including accuracy, repeatability, bias, agreement, and correlation to ensure that the method would meet stringent analytical criteria. Here we are outlining the method that we use to assess detection limits, detailing the number of replicants and blanks that were used. It's important to note that these MDLs reflect the entire analytical workflow, including sample handling, digestion, analysis, and the dilution factor. So these are real-world detection limits. It's also important to note that the ColdBlock lab and the ColdBlock vent hood is used for a wide range of samples. Very frequently, we are running samples for customers in the mining sector or in metal concentration or in specialty metals, all in the same vent hood that was used here. So there is certainly room for optimization in these detection limits, especially when cleaner acids can be used. In the next few slides, we will flip through the data that we've received and recovered. We'll present the summary results, but please, if you're interested in specific details, please don't hesitate to reach out to our team following the presentation. So we'll start here looking at average recoveries achieved across the CRMs that were analyzed. Again, you'll note that the data here includes data for mercury. Now, matrix spikes are a critical quality control measure as they demonstrate that the method can accurately recover target elements, even in complex or challenging samples, and even for elements like mercury and antimony. These results show strong recoveries for all key analytes in industrial sludge, underscoring the method's robustness and reliability. Here we are showing RFD values across all the CRMs. As you can see, most of the results are well below 5%. Even in difficult matrices like sewage sludge, the method demonstrates reliable reproducibility. Now, precision and reproducibility for challenging elements like antimony and silver were also good. You can see here with this method that we are overcoming some of the performance gaps that you would see with a typical 3050B approach. Data on this slide highlights consistent and reliable recovery of heavy metals, including challenging analytes like mercury, which again is not addressed by EPA 3050B, but is routinely measured with a ColdBlock digestion method. Our protocol safeguards volatile element recovery and ensures that heavy metals are quantified accurately, supporting a comprehensive environmental assessment beyond the scope of a standard method. These scatter plots provide a direct comparison between ColdBlock and EPA results for all 7 CRMs. And what they show are 2 methods that are highly correlated. The chart on the left shows for aluminum, and the chart on the right shows for lead. So you can see many of the points fall very close to the 1-to-1 line, and you can see very high R-squared values here, indicating near equivalent performance and validating ColdBlock's reliability for routine metals analysis when compared with an EPA protocol. This strong agreement across diverse certified materials demonstrates that ColdBlock is a credible alternative for compliance testing, and it's capable of reproducing the results or producing results that are in line with regulatory expectations. Here's similar data shown for arsenic, silver, and selenium. 3 elements that are especially challenging in environmental analysis. Now, antimony is well known as a problematic analyte in these kinds of digestions, often resulting in inconsistent recovery and or frequent need for sample reanalysis. The ColdBlock method addresses this challenging by adjusting the reagent timing, particularly that early addition of hydrochloric acid enhances antimony solubility during the digestion and leads to improved recoveries, even in complex matrices. Our data clearly shows that ColdBlock delivers higher antimony recoveries in about half of the tested samples, particularly in matrices that are prone to poor extraction under conventional methods. Now, these plots illustrate ColdBlock method for N3050B and how they compare for arsenic across multiple standard reference materials. Using a bland Altman approach to visualize method agreement and look for potential bias. This assessment confirms excellent agreement for arsenic between the 2 protocols, providing confidence that ColdBlock can be adopted without sacrificing accuracy or importantly, without introducing bias relative to the EPA methods. More data here is available as well. So, I guess in summary, I think with ColdBlock, we've developed a method here that achieves substantial time savings. Again, we've reduced a digestion that typically takes over 4 hours down to just 45 minutes. And I think through the validation process that we've run here, we're able to verify the accuracy and precision and confirm that this method is capable of delivering results that are equivalent to EPA 3050B, and to do so across a broad range of heavy metals and across reference matrices. With this method, we're also demonstrating enhanced recovery of challenging elements like antimony, and mercury. And I think this helps to address some of those known limitations that we spoke about before as it relates to traditional methods. The method that we've shown demonstrates very consistent performance across sample types, and I think this will help minimize the risk of sample reanalysis and support a smooth laboratory workflow. Now, I'd like to thank you for taking the time to join our presentation today, and I think what we'll do now is transition to a Q&A phase here. Again, the team is here and we're happy to take your questions. We'll pause for a moment and allow people to post their questions again. Use the Q&A feature that you can see there in Zoom, and we'll get started on answering questions in just a moment.
Thank you, Craig, for your presentation. Our first question today is, has this ColdBlock method been approved by the EPA?
Thanks, Heather. That's a great first question and one we've received numerous times. We've had a number of calls with the team at the EPA to discuss this. And to be clear, the EPA does not approve of specific equipment. They've stated very clearly to us that alternative technologies can be used if you can demonstrate equivalency or better performance. What matters is proving that the method that you're using can produce same or better results. So again, the EPA doesn't mandate specific equipment. It's up to you to validate that method and show that it's fit for purpose. So you simply validate your method in-house or according to ISO 17025 requirements. You must demonstrate equivalency to the reference method. And then all that regulators and accrediting bodies care about really is that your method is scientifically defensible, reproducible, and traceable to the CRMs and quality control standards. I hope that answers that question.
The next question is, what is different about your method that allows for accurate mercury recovery?
Thank you. So 3050B is designed really for metals that are stable during heating in nitric and hydrochloric acids. It's traditionally done in open vessels like hot blocker heating plates. So mercury really just behaves differently than most metals, and volatility here is really the big issue. So when heated in nitric or hydrochloric, mercury too forms species like elemental mercury or volatile chlorides that are just really highly volatile and can escape into the air. And that's exactly what happens when you're dealing with a hot block or a hot plate setup. When vapors are not condensed back down, mercury is lost. So that's what makes recoveries inconsistent and unreliable. And that's why the 3050B method explicitly says it's not suitable for mercury. So with ColdBlock, mercury isn't lost because of the cooling block, which is condensing vapors back down into the digestion. So even if mercury too reduces to elemental mercury during the digestion, it's reabsorbed instead of being lost. That's why you can confidently include mercury and show strong recoveries using ColdBlock, while traditional open vessel methods just can't do that.
Okay, we have another question. Can you speak to the scalability of the method? How many samples per cycle?
Yeah, of course. The entire ColdBlock digestion system has been designed for scalability. As was discussed in the presentation, for the process here, we use our ColdBlock medium digester. It's the medium-sized digester. It has 16 channels, so a single digester can run up to 16 samples at a time for the 45-minute digestion process. Now, the system is scalable in that multiple digesters can be connected to the same controller, and they could all be loaded up at the same time, and the exact same digestion can be run at the same time. So there's excellent scalability here. We often get asked the question about throughput capacity and throughput capacity improvements that can occur when switching to ColdBlock. And again, when you have the cycle time as short as we do, and with a similar capacity to other hot blocks, we're typically seeing, what we hear from some customers is up to about a 4 times increase in throughput capacity by scaling up simply to a double digester. And again, you can add up to 3, 4, or 5 digesters depending on the size of your vented and available space. So it's a very scalable system.
Okay, we have a question here. How about the digestion of silicate minerals?
Yeah, for silicate minerals, it's a question we often get asked for some of the samples that we do in the geochem side of the world. We have developed specifically a HF liner for our test tubes. Again, we're using quartz liners here for this process. We also have a plastic HF ready liner that can be used and can be used repeatedly. That liner will allow digestions to accommodate HF. Again, this method that was developed, we're not using HF, but other methods can be developed that use HF and that can completely digest silicate matrices.
Okay, can we run agricultural samples with ColdBlock?
Yes, absolutely. And we didn't really focus on that today, but you'll see on the ColdBlock webpage, there is a food and agriculture section, and you can see a number of app notes that have been developed using ColdBlock to digest those kinds of samples. And again, you're very often with agricultural samples, you're looking at different elements of interest. The method is slightly different, but it's even faster than the soils method that we presented here today. So absolutely, and happy to get on a call and answer any more detailed questions around the food and agriculture space where we've done a fair bit of work.
Okay, how does the ColdBlock method deal with organic rich soils? Do you see differences in recovery for certain elements?
Yeah, in samples with higher organic content, we are seeing improved recoveries of elements that are often, they can be bound up in organic complexes. And again, that's, I think, because we're standardizing that the peroxide addition. It ensures consistent oxidation of the organics across all the sample types. So yeah, we're seeing consistent recoveries of antimony, arsenic, lead, cadmium. And our data is suggesting that the ColdBlock reliably liberates these metals that can be sequestered in organic matter. So again, overall extraction efficiency improvements there.
Okay. Can ColdBlock be used for geological samples and ore grade materials requiring HF?
Yeah, a similar question to before, but absolutely. And again, if you see on our webpage, again, today we're talking about the environmental work on the soil analysis, but you will see on the webpage an enormous amount of work that has been done in the geochem space. We have customers from commercial labs to mining companies themselves, to specialty metal companies that are using ColdBlock for geological samples. So yeah, a lot of work there. You'll see a lot of it on our webpage. That's kind of our bread and butter and really where we got started as a business. It's why we developed our strong acid digestion method, which does use HF and led to the development of those test tube liners that I spoke about previously. So yeah, everything from precious metals to base metals to lithium, rare earths can all be digested using ColdBlock.
Another question, how do you handle highly heterogeneous samples without biasing results?
This is actually something we're actively investigating, determining how fine the sample needs to be to achieve efficient digestion in ColdBlock. I don't have a definitive answer right now, but it's part of an ongoing method development.
Okay, another question. What are the main maintenance or operational requirements for the system?
Great question. I'll start with the maintenance side of things. ColdBlock has been built in a way where we've really simplified a maintenance process. Typically we see well, certainly less than 10 minutes, probably closer to 5 minutes per week, which involves really a visual inspection of the unit, a wipe down of the inside of the unit. Very simple and straightforward to maintain without taking a lot of time and without any real replacement parts or consumable parts that are required. And again, that maintenance is done in your own lab by your own lab technician. It does not require outside maintenance or recalibration of any kind as the ColdBlock is used. So in terms of requirements, no different from any hot block. ColdBlock runs in a vented just like a hot block does. Same sort of ventilation requirements, very similar power requirements. ColdBlock does use a chiller for the cooling in the cooling zone that we spoke about before. Again, a lot of this is on our webpage, but always happy to get on a call and explain all of the infrastructure requirements for installation of ColdBlock. But again, very straightforward, a very simple transition from hot block or microwave over to ColdBlock.
Okay. Do you have any studies on copper concentrate samples?
Sure, we do. I'll get lots of questions on the geochem side here today, which is great too. Yes, we've done a fair bit of work on copper concentrates. A number of the large global commercial labs have done work on copper concentrates and have developed copper leaches that are very fast. You'll see on our webpage a number of notes that are there. Again, 15, 20-minute digestions there for concentrates.
Okay, the next question is, how do you handle matrix interferences in ICP OES or ICP-MS after your digestion?
So after the digestion, we dilute the samples appropriately, and we're running instrument checks to minimize matrix effects on the instruments. Our digestions are producing solutions with a higher chloride content than typical 3050B digestions. And for ICP-MS, we manage this using our collision cell and helium kinetic energy discrimination mode. And that reduces polyatomic interferences. And we're also using internal standards to correct for any residual signal suppressions on the machines. And then on the OES side, we're monitoring wavelengths carefully and we're applying background correction to avoid spectral overlaps. But overall, the ColdBlock method pairs very well with modern day ICP and ICP-MS instruments.
Okay. Well, we've had some great questions today, and I appreciate that.
Okay.
I think if there are any remaining questions, if you, I would ask anyone to reach out to our team. We've shared some email addresses there, and we can, of course, always be reached at info@coldblock.ca. We are already starting to schedule a number of meetings with labs that are running soils analysis. We're going to be booking a number of meetings throughout all of next week. So if you've got any lingering questions, or if you would like to book a call with Lori and the lab team to answer any specific questions on soil analysis, I'm happy to get those calls booked. Again, you can reach out to us at info@coldblock.ca. And we often get the question, how easy is it to take ColdBlock and try it in our lab? Recognizing this is a different method and again, a change from 30 years of practice that you've been used to following. We have developed a 90-day trial program at ColdBlock that allows labs for a fixed price to bring a ColdBlock in, get things set up, have direct connectivity to our lab team for initial runs and method development and verification work, and throughout a 90-day process. And at the end of the 90 days, you can opt to either purchase the unit, to enter into one of our subscription plans, which are very quickly growing in popularity, or return the unit, which we very rarely, if ever, see. But it makes it a great opportunity for you to take the 90-day trial is a great opportunity for your lab to bring a unit in and to give it a try. So I think we'll end the call there and stop the recording. Again, info@coldblock.ca if you got additional questions. Thank you again very much for your time today. It's been a pleasure to present these findings to you.